Hello everyone, welcome to our daily physics problem. Day number 39. Today we have a baseball impulse problem. We hit a baseball that's flying towards you horizontally at velocity of v with a bat. The ball then flies straight up to the sky with height h. What is the average impulse force of the baseball feels when the bat contact with the ball for 0.02 seconds? So, I want to pause the video, try it, come back to the video and show you how I did it. So welcome back guys. So first let's review what is meant by impulse. So impulse is the effect that a force exerts on an object for a given time, continuously. Then it's equal to the change of momentum of the object. So when the ball is moving towards your bat, it's moving at momentum of mv. Then after it hits your bat, it changes direction, go up with another velocity momentum called mv prime. So the changing momentum will be equal to mv minus mv prime, and the two vectors. The impulse will be the difference between these two vectors. So if we use some vector analysis, we can see the impulse will be this vector from the end of mv pointing toward the end of mv prime, and that's the vector for impulse. Then what is the magnitude of impulse? Because we want to find average impulse force. So the magnitude of impulse will be equal to mv squared. We use the Pythagorean theorem. It will be mv squared plus mv prime squared, or the square root. So we know v, but we don't know v prime. So how are we going to solve for v prime? So first let's factor out m to simplify the equation. Then we can find the v prime based on the information we know about the height it can travel. So by kinetic formula, we know v prime times t plus 1/2 gt squared be equal to h. Then what is v? V, it takes t time in order for the acceleration to stop the motion. So we know v will be equal to g times t. The magnitude of v prime equal to g times t. So g times t squared, we plug in, plus 1/2 gt squared equal to h. Then we don't remember g is minus, it's a negative value. So here we only consider the magnitude of the equation. So we can just make it to minus 1/2 gt squared. Then this one is positive, it's the opposite direction. So 1/2 gt squared is equal to h. Then what is the time it required? It's 2h divided by g square root. So let's plug into the first equation. So for v prime will be g times t equal to g squared times 2h divided by g square root. Here equal to 2gh and square root. So that's v prime. So we plug into our original equation, we have m times, that's better, it's fine. V squared plus 2gh and square root. Then we need to find force. So remember, force times a delta t be equal to impulse, the magnitude of impulse. Then force will be equal to impulse divided by delta t. Then we know the magnitude of impulse is m times square root of v squared plus 2gh. Then we divide that by our changing time, which is 0.02. Then we got our final answer here.